Now, okay. Alright, so this is lecture 10 about vector and matrix. So first we have this clip, which I suggest you watch before you continue. So pause this and go to the link and watch this clip. If you finish watching, then let's summarize some basic concepts, some main concepts that we will also have in this class. The first concept is that when we talk about vectors, there are three different students. One from physics, one from mathematics, and one from computer science. You think about vectors in three different ways, and these three are the same objects. They are just represented in different ways depending on how you use the vectors. If you are in physics, you think of vectors as movement. You apply some force to object, and that object gets moved to a new position or gets moved forever. If you keep exerting the same force to that object. Second is a math student. And we think about vector as some abstract object that you can do some operations like numbers. You can add, you can multiply by a scalar. You can multiply them together in different ways. You can find the size. You can do other stuff. And especially when we will talk about transformation, we will talk about how you think of vector, and then you perform some operations to that vector and get a new vector as a result. And you apply a sequence of transformation like you rotate, you scale, you flip, you do all these things. And we are interested in how all these sequence of operations can be represented just as a single operation. Just like if you think about if you move an object to the left one step and then move up one step, it's the same as you moving it to the upper left and in the diagonal direction one step. That's what I mean by a sequence of operations. And that's the math part. We will touch that a little bit as a concept. And then we have the computer science student who want to express everything as a sequence of numbers, so that you can perform some computations and get a result. And these students usually represent vectors as it's kind of like a vertical list of numbers, and sometimes horizontal. And that's the we will discuss about the representations later. But for now, that's the key concept about vectors. And we will touch a little bit on all these three perspectives to understand the final goal. Then, yeah, as the very first, like if you just have no clue, like if you don't actually need to use vectors anywhere, you can think about them as lists of numbers. If let's say if you buy some stuff from like department store or from online shopping website, and you can think of like you have a list of objects you want to buy. You want to buy the first object. You want to buy 3 copies. Let's say 3 shoes, 2 clothes, 5 earrings, something. And those numbers will get input into a system or a laptop, and so that the seller knows how many of each object you want, but they can send you the right amount. That can be just list of numbers that can be passed around. And the important thing about the list is that you cannot flip the list. The list is ordered. You put the square feet on top and number and the price in the bottom. You cannot flip them. They mean 2 different things. So that's a list of numbers. Next we have the lots of numbers that we will use in class. I asked the quiz that I can measure, but also as a verification. We will claim that okay, if you do this thing to this vector, you will get the result you want. But the only way to see that it actually does give you the result you want is to get the numbers and plot them on the graph and see if it actually works the way we intend. And then that's the very first definition of the vector of how you apply you think of it as an arrow from the initial point at this end to the tip, the other tip with the arrow symbol. I think it's the arrow tip, the triangle one. You think of it as moving or commanding, like telling something that to move from this point to the other point in the direction and in the distance indicated by this object. And eventually we will need to put everything onto the plane, onto the coordinate system, so that we can communicate, we can understand, okay, if you move one step to the right, two steps to the two steps up, then you end up in the green vector. And end up at this position if you start from the origin at this point. Or if I ask you, or if I give you different commands, and you're gonna move to different points. But by the way, this whole subject is called a linear algebra, and I think it's fun if you actually need to apply this in anything anywhere. And actually, if you are interested in AI, machine learning, any kind of like statistics, and you will need to use this linear algebra intensively. Oh, so yeah, if you want to be data scientist in the future, I suggest you take a full course on the linear algebra. But since this is just a general class, just to give you a basic mapping of the math areas you need to use in games and in anything basics. We only need to touch the basics. And yeah, some topics about three-dimensional vector. We also have the nice
The first tells you how far
animation.
along the x-axis. The second tells
I shouldn't put the sound there, but again you can. And just and some basic operations, which again we will have in this class, and what it means when you add two vectors together. You have to describe this both, let's say physically. When you think about, okay, what happens if you apply two forces from two different sources to the same object? What would the result be like? And also explain it computationally. As you can see there, you will learn how we add or subtract or do things with vector, and also understand what the result looks like. And I think this is the final one for the vector is about scaling. What do you mean by we multiply a number to a vector? Because usually if you think about what we have learned so far, we need to use, we have two objects that have the same sorts. You have two sets, you can operate them, you can combine them. If you have two numbers, you can do, again, operate some operations. If you have two functions, you can add functions together to produce a new function. But here, this is where you kind of apply a number to a vector. So these are two objects from two different areas. And that's a number, that's a vector. And we can compute it, of course, but we need to understand what it means to form that. And yeah, lots of numbers eventually. This is what you will see like on the screen when you run some program. Oh yeah, and this is the final goal, to understand what happens there. If you have the original image, like this pink pie creature, and then you move it, stretch it that way. Now what it means to perform this operation, and how you compute it, and what happens if you apply a sequence of operations, and what happens if you scale and move and scale. You scale and rotate and move and scale. What will be the result of all these operations? And so that's the goal for the first half of this class. So now let's get to the math and to something that we can compute. And so okay, let's back to the main page of the lecture, the vector and matrix. And I think that the first half already explained in the clip But now we need to get our hands on the subject to make sure we understand those new objects. Let's start from vector. We saw in the clip the ways to visualize a vector. We can think of the physical object. That could be the force you apply to an object. That could be the direction the object moves, the velocity, how is it moving, or anything. And then we have the math term, the abstract term. And then we need to know some kind of notations on how people represent a vector. And then the CS part, when we represent a vector as a list of numbers. And by the way, this is what they use in clip. But for the at first, it is easier if you write in this form. So these two objects are the same. They both represent a vector, where the first component, or the first number, the first slot is 2, and the second slot is this one. But we just need to write in different ways. This is easier to write because you can write it in line. And when you combine, you compare it, or especially when you compare it with a point in the coordinate system. 2, 1, that's a point. So that's a vector. Then you get the same arrangement, or let's say the same form. They just look similar, so you can imagine them. You can translate them back and forth. But then when we talk about matrix, you need to convert the vector in the horizontal form into a vertical form, because this is the matrix form. When you move a vector into the world of the matrix, we need to write in this way so we can multiply, or we can apply some stuff with it. Alright, so that's 3 vectors. Let's take a look at some definitions. So a vector is a specific quantity drawn as a linear segment. In this case, we are talking about the first definition. With an arrowhead at one end. Just that and that. And you just create a vector. Maybe it's a first vector for some of you, if this is the first time you study this topic. The distinction between these two ends, we call the first end is the initial point, which is where it begins or where it doesn't have the arrowhead, and the terminal point, terminate, or the end point where it ends, it's the destination. You can think of it as like moving from one point to the other, to the goal. So that's a vector. That's the abstract idea of the vector that we use in physics. And so that's a rough definition. And these are what we use. Whenever you see this kind of objects or this kind of quantities in physics, you first convert that into a vector. For example, if you think about movement, you have to be able to say where do you move from and where you move to. From this point to this point. That's a movement. Speed is a similar thing. You have to mention where you are moving to. And what's the speed? What is the direction you are trying to move to? And that's actually the v, which is kind of slightly confusing because we also use a vector as a v. So these two happen to have the same letter. And then we have acceleration. These 3 are like bundled in the same, like the same group. If you study calculus, maybe you have these 3 S. The movements, or actually I think they call the displacements. That's a fancy name for how you move. That's an S. Then we have the speed, which is V, and we have acceleration, which is an A. So these 3 are bundled together as a group whenever you see an object move, you can always ask about these three quantities. And then we have force. Force is another way to think about a vector. If you have an object on the ground and you put your finger, I don't know how to draw a finger. You exert the force and you push the object. It moves in the direction. And suppose that there's no friction on the ground. Suppose the object is on a plate of ice, and if you just exert a little bit of force, it just keeps moving into that direction forever until it hits the wall. So that's a force. Let's see where and the speed of this object that it is moving. So that's the physics way to think about the vector. And then we have both the mathematics and the computer science. Yes, sorry about the Bob text. Yeah. But first we usually represent it as a lowercase. That it depends on textbook, but I prefer using in these three notations because it has an arrow on top. It's pretty clear that if you see an arrow, you should think about a vector. But sometimes I use it as a bold letter, which I don't like. But sometimes if you see too many arrows, you would get like confused because there are too many arrows on the screen. So sometimes I use a boldface instead. And yeah, that's one way to represent vector. But we will try to stick with the arrow on the top. Second, you can think of vector as the definition here. The vector needs to have 2 points, the initial point and the terminal point. But if you start from a point P and then you end at a point Q, you can represent the vector. Oh, there's a point P somewhere on the grid. Let's say you have this plane. You draw this plane. You have a vector P there. You have another. Oh, sorry. You have a point P position, and then you have another point on a position Q. If you start from P and you end at Q, then you can draw a straight line and an arrow tip, and that's a vector for you. And the way we represent it is as P. It adds this notation. You write P and you write Q and then you write an arrow on top. So here it is clear that you start from P because that's the starting point, the initial point, and then you end at Q. That's the terminal point. And so that represents the vector from P to Q. And oh yeah, the arrowhead is to say that we are not talking about just a line. And we are talking about a vector like this. The initial and the terminal points matter. It's first and last. And lastly, we can talk about this is the computer scientist way of expressing a vector. And so if you have an initial point 0, 0, that would be the origin 0, 0. And you have another point A, B. Then when you connect, using the second way to connect from the initial point to the point A, B, then you just create a vector A and B. Notice how I use 2 different notations here and there. And for a point, I use a rounded parenthesis. That's the usual parenthesis you use in English because that's easy to type, and you use this point a lot more. For vector, like to distinguish between these 2 notations, you notice that they are pretty close, right? So to distinguish them, we use I think this is called let's say a sharp bracket. You can also find it on the keyboard. I think it's like to M and M and N. That's more difficult to find. Then the other one is above number 9 and 10, 9 and 0. So this is how we represent a single vector. Okay, so now we clear, hopefully, I clear out the way we represent them. Now we are ready. We are almost ready to do some math on it. So here we have this plane or this image. So you can see there are a blue vector and an orange vector. We know they are vectors because, of course, because there's an arrowhead on one end. So for the blue vector, this is we represent the vector as the point C, the point D, and an arrow on top of it. So that's a single vector. That describes a movement or a force from the point C to point D. And then we have another vector B. This is the vector where we start from the origin and end at the point B. On one hand, you can think of it as this point here is hidden here, but this origin is A and B. On one hand, you can think of it this way. But then on the other hand, since the A is the origin, and this point, this coordinate A and B, also describes how you move, how many spaces, how many blocks you move in both the horizontal, which is A, and you move 5 blocks to the right, and you move 2 blocks up in the vertical place. But you can use this point to represent this vector instead. And so this vector, this orange vector, is the vector A and B, which happen if from this image is the vector 5 and 2. So that's the x coordinate. This is a y coordinate. And one thing you can notice is this orange vector happens to be the same as the blue vector. If you draw a vector there, and then if you copy it, you move there, you can see they match. This vector and this vector, and these two vectors describe the same movement. It moved from the initial point to the terminal point by this command, by moving 5 steps to the right and 2 steps up. It also moves 5 steps to the right and 2 steps up. So these two vectors represent the same vector. This C and D are the same as the vector A and B. If you imagine, maybe if you imagine like 2 objects, 2 people on these 2 points, and if there's like a wind or something that pushed them both in the same direction by the same magnitude or by the same distance, they would end up into these two points, these 2 positions. So that's the definition of the vectors, how they move from one point to another. Then we will see how you can translate, or you can describe a vector numerically. Because for the third version, like for this orange one, it is clear that it is 5 and 2. And you just look at the point, and the point is the same as the components of the point is the same as the components of the vector. But for D, you cannot just use this endpoint because the endpoints can move around. So the way is so we need to have a way to explain this movement in terms of a vector, and how many space on the right and how many space up. So we have an example here. So we consider a vector whose initial point is the point P 2, 3, terminal point is Q 6, 4. And then we have to find the position vector. We find the vector between those points in terms of numbers. And so what you do is you just draw it. The point 2, 3, and you draw one. Yep, Let's just do it. 1, 2, 3, 4, 5, 6. And for the vertical, we need up to 4. So we have the point P, 2, 3. 2 means 2 on the x-axis, and 3 on the y-axis. That's the point P. And then we have the point Q, 6, 4. It is 1, 2, 3, 4, 5, 6. And then 4 steps up. So that's a point Q. And so we got the points. The points are just sitting there and nothing happens to it. Like unless we use a vector to represent the movement. So here the vector is from the initial point P to the terminal point Q. So first you draw a straight line and add a nice arrowhead. We know we talk about a vector. And then the question here is find the position vector. If we translate this vector, if you copy that vector, then you move it to the origin this way, what would this point be? And it's kind of clear from the graph, right? It's easy to see. Like, oh, it's actually 4 and 1. And you can see right away that it's 4 and 1. Like based on the graph. And again, make sure that you express it as a vector form with the sharp backlet. I think it's angle backlet or something, but so that's a movement, that's a vector. Let me write V also to give it a name. But then if you ask how to compute, how did you get a 4 from the image? And the 4 is from the first coordinate. And if you move from 2 to 6, you move from 2 to 6, and then I ask you how many spaces, how many steps you move. Alright, so you can see that 4 comes from 6 minus 2. Use the x coordinate of the terminal point. And you subtract that to the coordinate of the x coordinate of the initial point. So that's how you get a 6. And also, how to get a 1? You move from 3. 3 is there. 3 is there. You move from 3 up to 4. So that will be 1 step up. And moving 1 step up is you find that by start from the terminal point and subtract the initial point. That's how you determine the second coordinate or the second component of the vector. And so that's the position vector. We just find the vector from the 2 points. But if I suggest you just draw it and visualize it. But if you need, if at some point you need a formula, which I don't suggest, you can find the formula, sure. So if your point P, let's say it's x1, y1, x1 and y1 represent any number, any real number on the plane. And Q represents the x2, y2. And again, any number, any coordinate x2 and y2. Then the vector P to Q, it can be represented using the formula. If you go back, like you start from the terminal point, x2, and then so you subtract that to x1. And similarly, for the y coordinate, or for the second component, you use the terminal point, you y2 this coordinate, and subtract that to the initial point, y1. And so that's the formula for extracting a vector. So that's how you change. That's how you translate the points. That's how you describe a vector that connects 2 points. And then for the first part, the next thing we need to understand, at least memorize, is the definition of the unit vector. Because if you go back here, the vector can be anything. You can write from any point to any point. Up to you, up to your imagination. But there are two important vectors you need to know to be friend with. So we have these two special vectors called I and j. The I is represented as 1, 0. So that means you move one step to the right and you then move in the vertical direction. So if you go back and see the x and y plane, this vector I represents a movement to the right, one step. That's I. And let me add the other notation where you put the arrow on top. Then we have a vector j which moves up one step. Again, this is a vector j. So these two are the special vectors. Because actually any vector you have up here can be transformed or can be rewritten as these two vectors. Because again, and for any vector in the plane, you can describe its movement or you can describe its position by specifying the x directions and the y directions. This is exactly what you do here. And when you talk about right, you move to the right one step. And when you write the word right, and also one step, maybe it might be confusing for some people. Especially when if sometimes you use different scales on x and y axes. What do you mean by moving right one step? Do you mean you move to the next tick, the next mark on the line, or do you move one unit? And so we just make sure we get the same definition. We explain this kind of problem as this vector I. And this vector I mean you move to the x to the position x equals to 1 and y equals to 0. And so we have the same moving one step to the right rotation. And that's same as the j. And when we talk about moving up one step or moving up one unit, talk about this vector j. This vector j is defined as the vector 0 and 1. Okay, so these are the basics definitions of vectors. How do you define, how do you write, and how do you translate into the numerical notation. And next we will talk about the vector operations. But let's take a break